Alright, welcome back. Now it's the second part of mechanical and sound wave. In this part, we are going to learn about superposition of waves. Superposition, other words, is called overlapping. Okay, overlapping. When there is a superposition of waves, there's one condition when superpositions between two identical progressive waves, it will form a stationary wave. This stationary wave is also called a standing wave. If you look at it here, we have progressive wave and stationary wave. What's the difference? As the name suggests, progressive means the wave can move. Progressive, you see the wave is moving. When the wave is moving, it's called progressive wave. When the wave is not moving, we say it is stationary wave or standing wave. Standing, when you're not moving, you are standing, isn't it? The stationary wave does not move. Yeah, the stationary wave is not moving. Progressive wave is moving. Okay, but the important thing here is when you have two identical progressive waves overlap each other, overlap each other or superpose each other, it will form a stationary wave, or standing wave. But the condition is these two waves must be identical. Yeah, in what form? Yeah, identical means same. They must be same in terms of amplitude, must have same amplitude, same frequency. When you have same frequency, means you have same angular frequency, same omega, because omega equal to 2 pi f. When you have same frequency, means same omega. And also, they must have the same wavelength. When you have same wavelength, you have same wave number, because wave number k is equal to 2 pi over lambda. So in all aspects must be the same. Amplitude, frequency, wavelength, omega, wave number, all must be same. So we can say these two waves are almost identical. Okay, but they are different in only one aspect, which is the direction. These two waves must be in opposite direction. Okay, they must travel in opposite direction. One wave is moving to the right, one wave is moving to the left. When you have opposite direction, means the equation will be, one will be positive kx, another one will be negative kx. The wave that is moving to the right, the equation will be negative kx. The wave which is moving to the left, it is positive kx. Okay, so what I can say is stationary wave can be formed when there is a overlapping between two identical waves that is traveling in opposite direction. Okay, identical in terms of amplitude, frequency, wavelength, everything. But they must have opposite direction. The only one difference is the direction. One is positive kx, another one is negative kx. So if you look at the formula, since both waves are identical, both progressive waves are identical, so they have the same amplitude. So they have the formula, you see, they have same amplitude, they have same omega. See here, they have same omega. They also have the same wave number, because you see, same. Why is same omega? Because they have same frequency. Why have same wave number? Because they have same lambda. Okay, the only difference is one is negative kx, another one is positive kx. Negative kx means moving to the right. Positive kx means the wave is moving to the left. Maybe it's very hard to imagine what's happening here. So that's why I want to show you a simulation. Here's a simulation. Okay, if you look at here, I try to play here. We have you see a blue wave. There's a blue wave moving to the right. Okay, blue wave moving to the right very slowly. Another wave which is the yellow wave. The yellow wave is moving to the left. So you have two progressive waves. The blue wave moving to the right and the yellow wave moving to the left. And then you see the red one. The red wave is formed when these two waves, the blue wave and the yellow wave, superposition, overlapping each other, and that's why it produced the red wave. Now, I want to produce a stationary wave, standing wave, a wave that is not moving, a wave that is not moving. How to produce it? As I said before, what's the condition? What's the condition? These two waves must be identical in terms of amplitude, frequency, and lambda. Okay, so to produce a stationary wave, we must make their wavelength equal, right? Let me show you. Okay, let me show you. Okay, they must have the same wavelength. Okay, maybe let me make it smaller. Yeah, like this. Yeah. Okay. So if you look at here, the red wave is not yet a stationary wave. Okay. So how to make a stationary wave? So first of all, I adjust the wavelength to be equal. So I try to adjust the wavelength to 3. Okay. And then I adjust the amplitude to be equal to okay, A12, A22. And then the period, I adjust to 2. Period represent the frequency. Do you see that? Do you see the stationary wave? Do you see the blue one? Do you see the blue wave? Do you see the yellow wave? These two waves, the blue and the yellow, they travel in the opposite direction. They have the same amplitude. You see that? They have the same amplitude and also the same wavelength. Period also the same. Okay? And the red wave is called the stationary wave. Do you see the red wave is not moving? The red wave is always at the same position, not moving. This is called stationary wave. You see that? Okay. That's called stationary wave. Okay, back to our subjects. So stationary wave is happen when there is superposition between two identical progressive wave, but traveling in the opposite direction. So these two waves add up, we got a stationary wave. So now we y1 and y2 plus together, we got a stationary wave equation. We got a stationary wave equation when y1, this equation, plus with the y2, this equation, we get a new equation for the stationary wave. This is the equation for stationary wave. Well, y total equal to 2 amplitude because each of the individual wave is 1 amplitude. So when you add up, you get 2 amplitude cos kx sine omega t. How to actually add up these two equations? All right, we need to use trigonometric identity. This is the mathematical knowledge. You need to use trigonometric identity. That means you need to still remember sine A plus B. Sine A plus B becomes sine A cos B plus cos A sine B. When you have sine A minus B, you use sine A cos B minus cos A sine B. So you develop from there. You add up. Finally, you will get this equation. The equation for the stationary wave. Y total equal to 2 amplitude cos kx sine omega t. 2a cos kx is actually the amplitude formula. Amplitude formula. We can say that different particles has different amplitude. Different particle X has different amplitude. How to understand? Yeah, how to understand? Let me show you the simulation again. Different particles, or we can say different X has different amplitude. This whole thing, 2a cos kx, is actually the amplitude for different particles. Different particles has different amplitude. You see, let's play this stationary wave. Okay? So you see, okay, maybe I want to draw. Okay, you look at here. Here. This particle, if you compare this particle here, you see the particle? It only reached this position. Okay, and compared to this particle, it has amplitude 4. You see that? This particle can only reach to this position, and this particle can reach to this position. So we can say different x. Yeah, different x. Maybe this is x equal to 0.5. This one is x equal to all right. Let me just erase this. Okay. This one. This one x equal to 1. This particle here, this particle x equal to 0.5 can reach this amplitude, but x equal to 1 can only reach this amplitude. Do you see that? Even here, this one has 0 amplitude. This is the place where we call it knot. This is called knot. Okay, and the one which reached the maximum amplitude is called antinode. This one is called the antinode. Like this one at the center here. Here. This one is called antinode. So, different particles has different amplitude. Okay? Now, let us go back to the slides. So, different x, different amplitude. Okay? And the antinode can reach 2 amplitude. That's the maximum amplitude for the standing wave. Look at this one, the standing wave just now. The one with 0 amplitude is called knot. Yeah, called knot. This is the spell, how we spell knot, N-O-D-E, knot. And the one with the maximum amplitude, which is 2A, is called the antinode. Antinode. This is the antinode. Okay? Antinode. Anyway, between the node and the second consecutive node is one wavelength. This is one wavelength. Between node and node, it is half wavelength. Between antinode and antinode, also half wavelength. But between node and antinode, it is 1/4 wavelength. This is very important. Okay? Node and antinode is 1/4. Node and node is half wavelength. Antinode with antinode also half wavelength. Node and the second consecutive node is one wavelength. Now, to determine the position of node and antinode, how do we do it? To find the position of node and antinode. Yeah, as this one. You see that? How to get this position of where the node and antinode happens? How do we get it? Okay, as we know it, for node, the amplitude is always 0. For antinode, the amplitude is always the maximum 2 amplitude. Yeah, you understand that? Because the individual wave is 1 amplitude. When you add up, the maximum amplitude is 2 amplitude. Okay? So 2 amplitude is actually the amplitude for the antinode. So to find the position, we just take the amplitude formula, 2a cos kx, equal to 0 for node, and equal to 2 amplitude for antinode. Okay? So remember to put the modulus sign. Modulus sign because we have, if we look at the This one, we have sometimes we have the positive 2 amplitude, sometimes you go to positive 2, sometimes you go to negative 2 amplitude. See that? That's why we need to put modulus. Okay, let's consider the node. For the node, the amplitude is always 0. So 2a cos kx equal to 0, right? And then 2 amplitude, divide, you get 0 again. So cos kx equal to 0. So in what condition we will get cos kx equal to 0? So remember the cos theta graph? Cos graph is this one, the smiling graph. So when is cos theta equal to 0? Cos theta equal to 0 when pi over 2. When pi over 2. And also 3 pi over 2. So the next one will be 5 pi over 2, 7 pi over 2, 9 pi over 2. That's the position of the node. Okay? Then that is for kx. That is for kx. So to find x, we just divide by k. Divide by k, you get the x. K is 2 pi over lambda. But first you must know the lambda. Then you can substitute into the k. Then you divide. Then you get the x, the position of the nodes. Now for the antinodes, amplitude is 2 amplitude. Modulus, okay? So to remove the modulus, this one become positive and negative 2 amplitude. Okay, as I said just now, sometimes the amplitude is positive, sometimes amplitude is negative. Okay, so divide by 2 amplitude. So cos kx equal to positive negative 1. Okay, positive negative 1. So when is cos theta equal to positive 1 or negative 1? Yeah, cos theta equal to 1 when the theta is 0. When theta is 0. And cos theta also equal to negative 1 when pi. Cos theta also equal to 1 when it is 2 pi. So you can predict the next one should be 3 pi, 4 pi, 5 pi. Okay? Divide by k again. Then you get the x. So that's how you get the position of node and antinode. Alright, so do you understand how to get the stationary wave? It's the superposition between two identical wave, two identical progressive wave, but opposite direction, traveling in opposite direction, one to the right, one to the left. Okay, and this between node and antinode, between node and node, it is half lambda. Between antinode and antinode is also half lambda. Between node and antinode, it is 1/4 lambda. But between node and the second consecutive node is called 1 lambda. Okay, so stay tuned for the third part. See you. Bye.